Hey guys, today we are going to figure out what compounds are, and we're going to catch a fly. Compounds are substances that are made up of two or more simpler substances. The simplest or most fundamental substances that we have are what we call the elements. And we have a list of those elements arranged in the format of the periodic table. Each element is uniquely identified by means of a symbol and a number, starting with element number 1, hydrogen. In the previous video, I was playing around with three different metals: aluminium, tin, and lead. All three of those are elements and can be found on the periodic table. So if you can identify a substance on the periodic table, that means automatically that that substance is in fact an element, and it cannot be broken down or simplified any further. For example, lead is element 82 on the periodic table, and its symbol, funnily enough, is not Le. That would be too obvious. Its symbol is Pb. Tin is element 50, Sn. Aluminium is element 13, Al. In this video, I'm going to do an experiment with a compound made up of element 29, which is copper, element 16, which is sulfur, and element 8, which is oxygen. And those three elements combined in a definite ratio will form a compound known as copper sulfate, with its turquoise bright blue characteristic color. This blue version of copper sulfate is in fact a slightly more complex compound because it also contains water molecules that have been chemically bonded to the copper and oxygen elements. I'm going to perform an experiment where I'm going to attempt to remove those water molecules and simplify the compound. So I'm going to use a small evaporating dish, and I'm going to measure out the mass of a sample of copper sulfate, which I'm then going to heat over the gas burner. And then we'll see what mass we end up with afterwards. I'm just going to zero the scale. I'll add some of the copper sulfate. That has a mass of 8.47 grams. The heat from the burner is going to break the chemical bonds between the water molecules and the copper and oxygen elements. This will cause the water molecules to then evaporate off into the atmosphere, leaving behind a simpler compound. As that process occurs, we should see a change in color of the copper sulfate. Okay, we can see that the copper sulfate, the hydrated salt, has completely lost its blue color. It has a mass of 5.41 grams. Let's have a look at what we've measured so far. The blue copper sulfate, the hydrous copper sulfate, hydrous meaning containing water, we measured a sample mass of 8.47 grams. After heating, the white copper sulfate, or anhydrous copper sulfate, meaning no longer containing water, we measured a mass of 5.41 grams. The difference between those two masses will then equal the amount of water that was evaporated. If we now express that quantity of water as a percentage of the hydrous copper sulfate, we will determine that by taking the mass of the water and dividing it by the total mass, multiply by 100 because we want a percentage. We'll have 3.06 divided by 8.47 times 100 equals 36.1%. And what's interesting about that is that percentage composition of the water is always 36.1% for hydrous copper sulfate. And that is the unique thing about compounds, in that the elements combine in a fixed ratio. There is a fixed ratio between, in this case, between the water molecules and the copper sulfate. This is the anhydrous copper sulfate. Let's see what happens when we put the water back in. I'm going to put a thermometer in the beaker. At the moment we're reading a value of about 27 degrees C. That's the room temperature. Warm summer's day. The rapid temperature rise is an indication that a chemical reaction has taken place. So this tells us that a new compound has formed, the hydrous copper sulfate. In this experiment, I'm going to make another compound with these two compounds over here. This, if I mix these two together, a chemical reaction will take place, forming an epoxy resin. This is the resin, which is in liquid form, and this is the activator or the hardener, also in liquid form. When I mix the two in the correct proportion, that's the key thing, then a new compound will form, which once the reaction is complete will be solid. For every 1 part by volume of activator that I use, I need 2 parts of the resin. So there's a ratio of 1 to 2. It's important that I get that ratio correct to ensure that the compound will form correctly. So that's 60 milliliters of the resin, which I'm now going to put in over here. So now I need 30 milliliters of the activator. There we go, 30 milliliters. Okay, so there is my mixture. Now, like this, it's not going to give me the compound that I'm looking for, because at the moment, this mixture is what we would call an inhomogeneous mixture. Although I've got the correct proportions of the two ingredients, they are not uniformly mixed. So I need to turn this from an inhomogeneous mixture into a homogeneous mixture. That means that the ratio of the two ingredients is uniform throughout. That's the long way of saying mix it. So this is what I ended up with.
Mission failure.
Not exactly what I was hoping for. Two main problems. The resin is completely opaque, not transparent at all. So if there was something inside here, we wouldn't be able to see it. And I now know that dead bees don't sink. Little bee floated out, it's on its way up. This means only one thing. I've got to do this again until I get it right. But I did make a compound, and that was the main thing. So to recap and to highlight the key things to remember: compounds and the law of definite proportions. The main difference between compounds and mixtures is that compounds contain their various elements in fixed ratio by mass. Mixtures, on the other hand, can have variable ratios. Compounds are formed by means of chemical reactions. We know that a chemical reaction is taking place when we observe a temperature change. Hey guys, I hope you found this video helpful. Do the like, subscribe, commenting. And remember, don't stop getting it until you get it.